Hello everyone. Now in this lecture I want to discuss some important properties of DFT. Just like Z transform, just like DTFT, there are few properties of DFT which are very important. I am just only briefing the important properties. The first property is linearity. You know, DFT is a linearity property can be imposed on DFT. What you know, how we can generally write linearity. Okay, now in this video I am going to express only these first two, that is the linearity and periodicity, and in the consecutive videos I am going to explain circular symmetry as well as circular convolution. Now we can write linearity property as, let's suppose I have a x1 signal and a x2 signal with having certain fraction of a1 multiplied with x1 and a2 multiplied with x2. So as per linearity property, if there's the time domain signals are additive, then we can get the same feature in the frequency domain. So in equation wise, we can explain linearity property as, suppose I have a fraction of a1 multiplied with a time domain signal x1n, and it is added with a2 x2n signal. So as per linearity property of DFT, suppose this is the endpoint DFT we are doing. So it will be, we know the DFT of x1 should be x1 of k, capital X1 of k. So this x1 of k multiplied with a1 will be additive to x2, capital X2 of k multiplied with a2. So this is the basically empirical representation of linearity property. Now let's discuss periodicity property. Now what is the important point we have noted while determining DFT, that it is becoming periodic in the frequency domain as well as in the time domain. That means the periodicity property will be occur in time as well as frequency domain. So if suppose xn and xk, xn and xk, this is time signal which is periodic, and this is the frequency of DFT of this signal which is also periodic. Suppose if xn and xk are the endpoint DFT pair, because xn will be converted to xk, and using IDFT it goes vice versa. So these are, suppose these are endpoint DFT pair. Okay, so from this, if I want to write, it is having a periodicity property as well as this one is also having a periodicity property, and we know this expression or the equation in case of periodicity property, both are having endpoint DFT. This means both are having periodicity of n. So x of small n plus capital N is equal to basically xn. That means what is the value of xn here? It will be repeat after n sequences. Similarly, we can write x of small n, x of this is small k, x of k plus capital N will be equal to x of k. So this is the empirical representation of periodicity property of DFT. So in the next slide, in next video, I am going to explain what is circular symmetry. Thank you.